Good day to everyone. So this time we will be discussing logic statements and quantifiers. This is most likely a part of logic discussion for mathematics in the modern world by special depth. When we say a statement, it is a declarative sentence having a truth value. So when we say declarative statement, it's not a question. So it's stating um, or declaring something. So it has true value. So it's either true or false. But for logic statement, it's not possible for it to be both true and false. So it should have a truth value. So it means that it should either be true or false. Examples of logic statements are the following. So any kind of statement could be a logical statement. These are the symbols for statements. It is conventional to use lowercase letters such as the P, Q, R, S. So those statements should be named with this lowercase. So, for example, the P, that's today is Saturday. Q, today I have a math class. R, 1 plus 1 equals 2, and so on. So we use this instead of the statements. When we say compound statement, it is revealing, or it is composed of two or more ideas, probably two or more um, statements. It made use of logical connectives such as the following. So what are these connectives ba that we are referring to 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 put together different simple statements? So that's simple. It's not usually maraming symbol. There are plenty of symbol used for not. Sometimes we use this one, not P, and sometimes we use this P prime. So it denotes negation of the statement. So later I will give you examples. P and Q, that's conjunction. It made use of connective the end. So you are putting together two statements. When you say or, this is a disconjunction. So it's just like you are asked to choose one. No, either or. Yan. So this symbol is used. If P then Q, this is a conditional. So if you were able to perform, or if the first statement P, or if the statement P is true or performed, then you will have the promise then, or the condition. That's condition. And then P, if and only if Q. So this is called the biconditional. So they are both conditions, and they are both also the terms. So this shows relationship from first and second statement. Unlike the previous one, it's from P to Q. The last one, the biconditional, shows from P, Q, and Q to the conditions, the relationship between conditions. Some example. So P refers to it is raining, and then Q is Daisy is playing ball. So when you say P and Q for letter A, it is raining and Daisy is playing ball. If we have P or Q, it is raining or Daisy is playing ball. If P then Q, if it is raining, then Daisy is playing. Not P, so it is not raining. Because P shows it's raining, so therefore not P is it is not raining. That's very logic is a very logical, a really very logical subject that you read. But what makes it difficult is the complexity, and it's too much very practical in logic. Kaya medyo mahirap siya sa iba. Let's examine the truth table. So it's very easy to identify the true value, no, of a statement. But what if we have compound statement? It's really difficult to identify the truth value of that compound statement. That's why we need to use truth table. When we say truth value, again, we recall that it's it is either true or false for a simple statement. Now, the truth value of a compound statement, it depends upon on the truth values of the simple statement. That's why we need to construct a truth table to identify step by step and to be very vigilant on identifying the truth value of the compound statement. Kasi ganun siya medyo complicated. If it's just two simple statement, easy. It would be very easy. But what if you're dealing with more than two? It will be more complex. So the formula for constructing truth table is, let's say for example, you have two statements. The first thing that you have to do is to construct the combination of truth value between these statements. So we have here two statements. I decided to start with the least possible compound statements. So we have two, the A and B. So there are many possible combinations. It's either both A and B are true. It's either A is true and B is false, and then A is false or B is true, or they are both false. So these combinations, you have to fill in all the combinations of the truth value of the statements that you have. And then after that, we can now identify the formula for the truth value. So if we are going to make a conjunction between A and B, so we are making use of N. When we say N kasi, they're together. Both the first statement and the second statement should be both true because they go together as the word N implies. Therefore, the only true from this compound statement A and B is only when A is true and B is true. So if you're going to have the first statement true and the other one is false, since they go together, the whole statement will be false then. So you just have to remember that when dealing with N or conjunction, you have to make sure that both statement is true, A and B, or all the given statements are true for them to be true. That's how complicated A and is. Kasi end siya. Now, I hope you get me clear on that, on the explanation of that statement. When you say or, as what I have mentioned earlier, you have an option to choose from. So the truth value depends on the existence of a true statement. No? For example, this one, they're both true. So therefore, if even if you choose one from this, it will be true. From the second example, the first statement is true and the other one is false. Since you have an option to choose because it's an or it's this conjunction statement. So at least one is true. That's A. So the statement or the compound statement will still be true. That's also true on the third example. So the third combination. So, but for the fourth combination, since they are both false, either you choose one of that, you will be using false. No, so you have to make the true value of that to be false. Yeah. A prime or not B. So so we are just focusing on one statement for negation. So if A is true, if you're going to negate that, it will be false. Of course, very simple to identify, to understand. If it is false, then if you negate that, it will be true. For example, let's make use of this example. Let's start with negation. Negating. You get an A in math. That's true. If you're going to say it's false, let's say you were not able to get A in math. So that is false. Because the statement should be true because you get an A in. Okay? You get the point. So the value of A is true. Okay? If you negate that, you will be false now. So parang simple lang siya. If this is the statement, if you're going to negate that, then you'll be wrong. If you're wrong, and if you negate that wrong statement, they will be true. So I hope you get what I. Yeah. Let's have the conditional and biconditional. Again, we have to construct the combination of true value of each statement, combinations of true values of each statement. So here again, we have true, false, and false for A and B. So if we say that if A, then B, so we are saying that we have fulfilled the first statement B kasi ito say siya yung A. So if this A is fulfilled, therefore you have to give your promise. That's the B. Now, if the condition is met, you have to perform B. So let's say, for example, in our statement, if you get an A in math, then I'll give you $1. That's the condition. So if you get an A, then I'll give you $1. So what if they're both true? Of course, you are performing the true promise. No. What if you get an A in math, it's true, and you did not give him or her $1. Therefore, you're not fulfilling your promise. Even though that someone get an A in math, you were not able to fulfill the promise of giving $1. This should be false. No, this will only be this is for the condition if the condition is true. If the condition is false, yes. For example, you were not able to get an A in math. Either you perform the promise or not, it will be true. No, for example, you get an A in math, then you were given $1. That's not a problem. It will still be true. No, no, even though it's a conditional, no, even though it's a conditional, as long as the condition is not met, hindi naman na met yung condition. So you can choose either to fulfill your promise. And anyway, there's nothing wrong with it. Do you get what I mean? Yung parang yung parang if you were able to sleep in the afternoon when we were kids, and we were able to sleep in the afternoon when we wake up, uh, our parents have a present. But very seldom or not at all that when we wake up after sleeping in the afternoon, there is no present for us. We need to have some food to eat. Na parang ganun sila kasi. Now, if for example, this condition of your parents is not met, for example, you were not able to sleep in the afternoon or in that specific afternoon of a day. So there's nothing wrong if your parent will give you food for that day, or it's not wrong as well if he or she will not give you food on that afternoon. Yung merienda, yung Filipino term. So kung bibigyan ka niya ng merienda or not, that's not a problem kasi you're not able to fulfill the needs. That's we mean by conditional. So for if the condition is met, once again, if condition is set or is true, so the condition should be true for it to be true. Or if the first statement is not met, it's false. Whatever you do, whatever you okay. But for biconditional, it's not possible. No. Kasi for biconditional, you have to test it on both sides. If A is true and B is true, therefore on the other side, if you fulfill B and if B will be the condition, then A should happen. So if you do that on the second example, uh, if if the condition A is met, then you'll do the second. Then but in this case, you were not able to to fulfill your promise. That's why it's false on conditional. And it's also be false on the biconditional because if you were able to meet the promise of F, diba? So yeah, you perform your promise. That's for the biconditional. So dahil for biconditional is that both conditions should be met true. Should be done. Both simple statements should be true. A is true, B is true. A is false, B is false. It's still true. No. Kasi condition siya eh. If you did this, I'll give you that. That's true on conversing the two simple statements. So kung hindi mo na met, the condition is not met, then the promise will not be done. So that's true also when you put it inversely or vice versa. So it's only true for biconditional if both statements are false or true. Let's construct a truth table for the formula not P and if P then Q. So if this is the type of the question that you have to go through this one by one. So ang una nating i-interpret dito is to identify what are the simple statements. So you only have two statements here, P and Q. And then after identifying that, you have come up with the combination of truth value. So we have here true for P, true for Q. That's just like earlier. So these are conditions. True, false, true, false. The first one that we have to identify are the simple condition. So we have here not P. So if not P, if it is true and it's not true, that's false. If you negate the true, it will be false. If you negate the false, it will be true. Next, then Q, as what we learned earlier. So if the first statement or the if statement is true, then you have to have the second statement or second statement to be true as well. So if we have the true for true, false for true, false. Kasi hindi mo ginawa ko. Kasi ganun the condition is true mo siya. And then, since this condition is not met, this condition is not met, so either what you do, either true value you have for the second statement, it will still be true. So this is our now coming from this. So we have this first one that we have the if then for P and Q. So we have to combine now the truth value for both states. And remember in end, so it has to be both true. So if you observe, FT will be false, FF will be false, and these last two statements will be. Yeah. That's how you do it step by step. So you have to come up with a simple compound statement before you go through the complex. It's just like simply performing or solving mathematical expression. No? Kailangan mo unahin yun sa groupings, as well as yan. Now, when we are this, we are able to get the final put value. No. What do we mean now by tautology? Tautology, compound statement is that is for all possible combinations. So lahat ng magiging outcome niya is true. On the other hand, pag naman lahat siya ay false, then that's a contradiction. So let me give an example. We have proved that if P is P, if P and Q, or if Q and P is a tautology. So kailangan natin ma-prove na ito ay tautology. So first is we have to have the combinations of ano yung mga statements na P and Q. So again, we have to summary lang ng P, F, F, E, F. So we have to go first with if P and Q. So alam natin na true lang for 2 and 2 and for T and F, and the rest it will be na hindi naman na-met yung condition F. Now, if you go through the other side, yung naman yung titignan natin, this will be true, this one will be false, false yung condition, baliktad siya ha, so still you do the promise, that will still true. This one, the condition is true, but you did not fulfill the promise, that's false. And then the condition is false, so therefore, you will not be given the promise, that still be true, or that still be valid. Now we are going to combine these two compound statements root value with or. Remember with or, at least one should be true for it to be true. So dapat may isa doon na true para kapag namili ka kasi or siya it's you are choosing one statement between the two. This you're making an option. So if there's at least one true there, it will be true. So if this is so true, that's true. One is true. There is one true, that's P to Q or true, and this is true. Of course, this will be true. So you can read that all the outcomes are true. So this is an example of a tautology. Tautology siya. So if it happened that all the outcome is false, that's called a contradiction. Now let's go to quantifiers. When we say quantifiers, the words that will make the simple statement, that will make the simple statement confusing. But we have to be aware of the definitions of each quantifier. So the word all, some, and none are examples of quantifiers. There are plenty of quantifiers. There exist. Yeah, they are called quantifiers. A statement containing one or more of this word is called a quantified statement. So we are quantifying the statements or of how many there should be there. So note that the word some means at least one. Meron kasi tayong maling connotation When we say some, We are saying it's not all. So parang nagiging ano siya eh, nagiging iba yung meaning niya. So we have to stick to the definition that when we say some, it means that there's at least one. So it doesn't matter kung lahat, basta at least there's at least one. So we can say that it's so here are the example of quantifiers. According to your everyday experience, decide whether each statement is true or false. So ito parang ano lang. Tatry lang natin tingnan yung ano, yung truth value niya gamit yung mga quantifiers. All dogs are poodles. Is it true or false? Syempre false 'yan, no? Kasi we can name, this is our A dogs and our B is poodle. There is subset of A that is not in B. So we have Dalmatian, we have Dachshund, we have Shih Tzu, we have Pomeranian. That is not in poodle. So therefore, you cannot say that all dogs are poodles. All the dogs might be not poodle. No, so this is false. Actually, kahit di na natin explain, alam natin na mali. Some books have hardcover. Yes, there is at least one book that have hardcover. Minsan hindi lang isa in a books. So, meron talagang hardcover. That's why the word hardcover exists kasi meron. No US presidents resident of Georgia. Ito kailangan natin mag-research. Siyempre, bago ko ito ibigay sa inyo, nag-research. So, there is at least one. No, meron tayong at least one US president that were resident of Georgia. That is Hag Carter. Okay? So, some cats are mammals. Ito na yung confusing. Some cats are mammals. Some means at least one. At least one cats are mammal. So we are not referring to not all. So pag sinabing at least one, the minimum is one. So it could be all. So this one is true. No. So some cats are mammal. There is at least one cat that is mammal. Actually, they are all. No. At least lang naman yung binibigay niya. Some cats aren't, ito lang yung mali. Kasi some cats aren't mammal if statement 4 is true, ninegate lang siya. So, ibig sabihin, if you negate this true statement, it will be false. So, number 5 will be false. Kasi, some cats aren't mama. So, sinabi niya, there is no at least one cat that is mama. So, that's not true. There is at least one cat that's mama. Actually nga, lahat. That's what I mentioned. In mathematics, there are two types of quantifiers. Kailangan natin siya i-maisingit. So, we have universal quantifier in mathematics. So, ang ibig sabihin ng universal quantifier, we are in universal quantifiers, we are stating the total existence or the total non-existence of something. So, for example of universal, none, no, all, every, in a statement. So qualifiers, this denies existence of something, yung mga none, no, while you all and every asserts that every element of a given satisfies some condition. So example of universal quantification of P of x is proposition in any of the following forms. So P of x is true for all value of for all x, P of x. For each x, P of x. For every x, P of x. Given in any x, P of x. All of these example or propositions only symbolically denotes for all xp of s. Etong symbol na yung inverted a, that means for all. No, it denotes universal quantification. So for all x, p, so there exists p of x. So universal quantification can be extended to universal variables. Example, the statement any real number x, we will have x squared greater than or equal to 0. So this is true, of course, no? Symbolically, alam naman natin na totoo to, no? Whatever number it is, when we square that, no, even negative, positive, when we square that, it will be positive, and then it will be greater than 0 or equal to 0. So the least possible value is 0. So we can write this that for all x that is element of R, element of real numbers, I hope you're familiar with this, is x squared greater than or equal to 0. So since there is two statements given here, we can use another way to represent that one. That for all x, there exists x as element of real number, and x squared is greater than or equal to 0. So the second form is a bit weird, but could be used in some situations. So the other one is the existential quantification. Actually, quantification is a negation of a universal quantification. So pag sinabi nating existential quantification, there exists an x such that p of x. So ibig sabihin, not all of x, p of x. Ibig sabihin, there's just exist some siya. For some x, p of x, there's some x such that p of x. So there's at least an x that is p of x. So you're writing simple that there exists x such that p of x. No? Kasi yung list ko ng external quantifier can be extended in several variables. Yan. Again, if that's not true, example, magbigay tayo ng example para maintindihan. Yan. For example, eto kasi, it's not true. Yung kanina kasi, yung example natin kanina, tama siya. Eto, you cannot held this one true. For all x, x squared is greater than 2. Actually, this is false. No? Kasi, yung x equals 1, and kapag in-square natin yan, 1, and 1 is greater than 2, is false. No? False yan. So, to negate this statement, dahil false siya, we will going to negate this one to make it true. Alam natin yan, di ba? To negate a statement, it will be true. Kaya natin siyang gawing true. So, kailangan natin, if this is P, no, we have to get the negation of P. And the negation of P is that you should only state that there exists X such that X squared is greater than. So, hindi mo sasabihin na lahat. We will only state that there are some. Okay, so this is P, which is false. So to make it true, we have to state that there exists X that's such that X squared is greater than. So yeah, ito yung ibig ko sabihin that an existential quantification, yan, yung reversed P, is a negation of universal quantification. Yeah. So, example, ito pala may example pala. There exists number X such that X is greater than 5. Yan. So we cannot say that all number X, hindi ka pwede mag-universal kasi may mga number that's less than. So we should only explain that there exists X that is a real number that's greater than 5. Not all. Okay. And that ends our discussion about, medyo basic pa lang, no? About logic statements and quantifiers. Medyo logic pa lang ito, pero at least you have learned the basic and some of it. So maybe soon I will be uploading much more complicated example of logic statements. So that will be all. See you again on my next video. Bye-bye. Don't forget to subscribe.